So, we finished example 1, right? 2.6? Yeah, we finished example 1, 2.6. And what we started to get into was maybe I don't actually need to graph this thing to know where it's above or below an axis, because parabolas have behavior, right? Happy parabola, sad parabola. So if I know the zeros, like one of them is here and one of them is here, and I know it's a positive parabola, well, then I know it will be negative here, positive here, positive here. Okay? So that kind of end behavior can be used to shorthand your way through the problem without actually graphing it. As long as you know what the zeros are, testing in those intervals doesn't involve putting a number in, it's just I know the thing. Snack goblins, I swear. But it's right there! Won't even wait for me to open the box. Yeah, with class, right? You know, the stuff that we're doing. All right. So, you go ahead, example 2. Come on, Frank. There we go. Why are you not big? Why are you not big? Go big. Okay. First up, I got to find zeros, right? Like the whole above or below the axis, greater than or equal to 0, less than or equal to 0. That's always going to happen at the zeros, so find them. Are we there yet? Can we figure out how to turn this into split factored? Okay. If not, you got a whole tool bag, right? How are you going to find the zeros of this thing? We have Descartes' law of signs, we have rational root theorem, we've got all these things, but in the 21st century, we just kind of plug ourselves into the matrix and say, I feel lucky about what? Okay. A voice from the ether tells me we feel lucky about -1. That's a 3. So, -3, -7, 7, -6, 6. Yay, it works. I heard another voice say something like 3. I wasn't really sure. It was a little fuzzy. I couldn't hear it too well over the sound of snack goblins. Crinkle, 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 crunch, crunch. I take 3 by 3 and I get 9. 2, 6. Yay, it works. And then probably a -2/3, right? Because this is now 3x plus 2. I took a cubic and I reduced it to this many degrees. So, if I look at a number line, I'm going to have at -1, there's a 0. At -2/3, there's a 0. And at 3, there's a 0. What we would do before is we would test in those areas. Maybe I would dump this into y1, and then I would plug in -2, -4/5, 0, and 10. I'd pick numbers that are in between these zeros to figure out if it's positive or negative, if it's above or below the axis. What the end behavior can tell us is Nah, dude, you don't need to do that at all. This was a positive odd function. What does a positive x to the odd start at for a left end behavior? Right? They start down at negative infinity. Yeah, everyone do the dance, right? Okay. It's going to start down at negative infinity. It's going to do stuff and then go up to positive infinity. So I know if these are the zeros, it's going to start down here at negative infinity. Good thing I know about behavior of zeros too. Does it go through at -1 or does it bounce off of it? Like a line, it'll go through it. So then it'll be positive. Does it go through -2/3 or bounce off of it? Like a line, it'll go through it. And I know at the end of the behavior, it will go up to positive infinity. So I don't actually have to graph this. I don't have to plug any numbers in. I just got to find my zeros, and then I know the behavior. Behavior tells me positive or negative. And then I answer the question, where is it less than or equal to 0? Anywhere it's negative, right? So would it help if I put positive and negative infinity here? Because then you could say, well, it's going to be from here to here, parenthesis or bracket. Because it says or equal to. And then from here to here, it's also negative or less than 0. Shove a union in between them, you got your answer. Okay? Now, could I just look at my screen too and see whether it's above or below the axis? Yeah. But I'm going to give you every tool that I can because depending on the problem, depending on the context, you might need different information. You might need different tools. Yes, ma'am. You sure? Okay. So I would write my final answer, negative infinity to -1, parenthesis, bracket, union, bracket, -2/3 to 3, bracket. How does this change if I say less than 0 instead of less than or equal to? Okay. I just hand back those tests. There's a number of you that on the analysis parts literally just got the difference between parentheses and brackets wrong. Something so tiny, okay? So be careful that bracket means equals, parenthesis means doesn't. So you find the zeros. I know that we can look at our calculator screen and half the time, if it's an integer, we're going to just see what the zeros are. I would like you to have the synthetic division to at least back it up. I want to have some sort of math there to back up how you got the zeros. And then if you just get your cute little number line on there and write your answer, good enough. However you test in that interval on the number line, I don't care. I just want to have some sort of work, and I think some of you see the benefit of that. Get rid of 2a, that's just quadratic, let's do 2b. I think some of you see the benefit of that on your tests. If you showed enough work, how many of you just got the one little off and that's it? Got the one little off with the domino, okay? I want to give you credit for the work you do correctly, so the more work you show, the more knowledge you're demonstrating, okay? I forget who it was, but I swear there was someone who did one of those big, like, 10-point problems. Whole thing isn't even close because they called it A to 3, like when they wrote down the problem. I gave him one off because they did it right, just with the wrong number. I want to give you credit for that. So please show work, even though I know you could probably just look at the screen and say, yeah, it's here. Back it up, okay? For the handful of you that were missing the Chapter 1 packets, remember, I'll take stuff all the way to the end. I'm not going to be that person who penalizes you for late work. I just want you to do the practice. Okay, fairly quick. You find the zeros however you're going to find them. So that factors 45, 45, 5, 9, 5, 15, 3, 12. That one adds up. So 1 and 6. Yeah. On a hunch, if I did that, could you take it from there? Factoring? All I did was break 7x squared into 6x squared and 1x squared. Okay, so I'd take out 2x squared, leaving x plus 3. I have a x minus 15, x plus 3. X plus 3 comes out, leaving 2x squared plus x minus 15. Only way you're going to get 2x squared is with a 2x and an x. Rep the factors of negative 15 real quick and get plus 5 minus 3. Nope. Plus 3 minus 5, other way around. There we go. So, if x is negative 3, positive 5 halves, and negative 3 again, right? We know the behaviors of these zeros. So now we know that at negative 3, it's going to bounce off the axis, and at 5 halves, it'll go through like a line. I also know, because it's a positive x to the odd, it's going to start down here at negative infinity. Now I know it's going to bounce off of this and continue back into negative town. Then it'll go through this like a line up to positive infinity, because the general behavior of the graph is like this. I don't need to know anything else besides that other than where it's positive and negative. And then I answer the question, where is that greater than or equal to 0? Five halves to infinity, I think we can agree on that part, but because it says or equal to 0, we ran into this like chapter 1, section 1. How do I say 3 but only 3 in interval notation? I just put -3. Don't put -3 to -3 in brackets. It's redundant, it's not simplified. It's like Mr. Sirman guy dude.
That makes sense. That's just me trying to remember something.
Okay. So find the zeros however you did. I'm guessing everyone just did synthetic division. But you find the zeros. If you got the number line and some work to show how you got the zeros, we're good. All right. Solve each inequality. They're all quadratics. And you would think, well, we already did quadratic. Quadratics are easy. Find the two zeros, and it's just happy or sad. Do y'all remember discriminants?
Nope. Not one bit.
For everyone who's so in love with quadratic formula, I would hope you remember it. That's the discriminant. Remember, it's the thing inside the radical, because if I do square root of a number, I get plus or minus 2 real zeros. If I do square root of a number and I get 0, well, plus or minus 0 is just 0. I will get 1 real solution. If I do square root of a negative number, that's illegal. No real solutions. So if I take a peek at this and say 5 squared minus 4ac, 25 minus 32 is -7. If my discriminant is negative, that means I don't have any real zeros. What I'm getting here is these two are the same thing, just different inequalities. I'm going to get a graph out here. And then I'm going to ask, where is that less than 0? So what's the answer? There's no solution. Empty set. There is no interval in which this is less than 0. But then if I ask, where is it greater than or equal to 0? All real numbers. C and D are special. Do you recognize? Look at the numbers. Perfect square trinomial. This is the quantity x minus 5 squared. And if I remember vertex form or transformation form of a parabola, this just means I'm going to take a normal parabola and move it where? Bass-ackwards land. We're going to the right because it's grouped in with x. So I'm going to have a parabola that does this with a vertex at 5, 0. So when I ask, where is that greater than 0? Not everywhere. That one point, it equals 0. So I have to say everyone except that point. It'll be negative infinity to 5, can't touch us. And 5 to infinity. It's greater than 0 here. It's greater than 0 here. You just have to exclude that one spot. Okay, what if I said less than or equal to 0? Just there, right? It's never less than 0, but it equals 0 at exactly 5. So these are just special instances where sometimes I can determine real zeros or imaginary zeros, special forms of a function. And again, I don't really have to graph it. I just know the behavior of these functions. And then I get these special answers where instead of an interval, it's something funky. So go get funky. Math monkeys. Those funky monkeys. Okay, so these are quadratics with kind of special characteristics. If you figure out where that vertex is, you'll probably be fine. Okay, pretty quick, I hope. So that 1 Minus 2 is negative 1, 4. Yeah. Okay, so the first one, okay, earlier I had put the discriminant up there. That just tells me real zeros or not. You remember you could just find where the vertex is too? Negative b over 2a, plug it in. If I find out my vertex is going to be at negative 1, 4, well, that's above the axis. If it's above the axis and a positive parabola, that means it's headed away from the axis. It's never going to touch the x-axis. And if it never touches the x-axis, that means there are no real zeros. So it's just, again, a different set of tools for the problem. I would like you to have some sort of work, something to back it up. And that something might just be a sketch. Like those sketches in the middle. If that's your reasoning before your answer, all right, fine. But this isn't going to have any real zeros. So when I ask where is it greater than 0, yes. When I ask where is it less than or equal to 0, no. Contestant C and D, again, if I want to find zeros, I put everything to one side of the bus. I see another perfect square trinomial, which is parabola shifted right 1. So it hits the x-axis at 1, 0, bounces off. So when I ask where is it less than or equal to 0, there and only there. Where is it greater than 0? Everywhere but there. That's a really, really bad infinity. That's like a pug infinity. Be honest. Like pugs, that was just animal cruelty. That was specifically breeding animals for a shorter and shorter face until the point that they have no nasal cavities and now they're just suffocating all the time. It looks like a normal dog ran face first into a wall.
I don't think a group of pugs is called a grumble.
Okay, that's hilarious. A grumble of pugs. Y'all, could you do this by just type it into Y1, look at your calculator? Yeah, but I want to give you as many tools as possible. I do want to go through this because there's another way to do this. Clear. If I go x squared minus 2x minus 15, and then the line negative 16. If I graph that instead, oh, we're going to have to go a little bit lower. Come on, Frank. Come on, Frank. You can do it, Frank. If I calculate the intersection between these two, take a wild guess what the x value is, right? So you could find these x values by also doing an intersection if it's not set unequal to 0. It doesn't have to be 0, it's just 0 is the easiest number to work with. It's still going to be 1. If I asked, where is this greater than 0? Or sorry, where is this greater than negative 16? It's still everything up to 1, everything after 1. The answer is still the same. All right. So we did polynomials. How are we feeling about it? I got this. Yeah, a little sketchy. I don't know why we do this one thing over here. And dude, what? Okay. So the parts that usually get weird on us are, we can find the zeros of polynomials, right? Like, however you do it, whether it's factoring or what do I feel lucky about, do some synthetic division. And then, you know what, like, I hate you. Frank.
Come on, Frank. Come on, Frank.
Buddy. All right. Y is clear, clear. So what is that? 3x to the third minus 5x squared minus 74x. X squared minus 74x. What is this? 10, negative 24? Okay. Y'all, it was a positive odd polynomial. I know it's going to start at negative infinity, do some math, go up to negative, or go up to positive infinity. Did I say negative first? No. Sometimes this isn't going to look too decent, but can I see the kind of the tilt of those lines? They're not really lines, but zoom fit, we kind of have a love-hate relationship with that. Zoom fit zooms to what are supposed to be the relevant features of the graph. You would think x and y intercepts and extrema. Sometimes it'll do that. Sometimes it makes the window go out to the thousands, and I don't know why. Can you see, though, from negative infinity to infinity, zeros at negative 4 at something, and at 1, 2, 3, 4, 5, 6? Can you see that it's negative here, positive here, negative here, positive here? Okay, I can use that to test. You don't have to go super hardcore on it. I just want to give you all the tools for it. You just tell me where that is, greater than 0 or less than 0 or whatever it may be. Pay attention to your parentheses and brackets. Like I said, I don't know why. I don't know why. Okay. Dude. Okay. So if I back up to okay. You don't have to go all the way back to this. When we're finding a polynomial inequality, the only places that it switches from positive to negative are where? Okay. What's different about a rational? Let's say, for example, I had a graph like this. Say I had a graph like this. Where does this switch from negative to positive or positive to negative? It can switch at asymptotes or x-intercepts or asymptotes. Okay, so it goes from negative to positive to negative to positive. So it's the same thing as graphing these. You need to find your x-intercepts and your asymptotes, and I would put them on my number line like maybe this. It'd be at, say it's like -5, -2, 1, 3. I would put my little number line like this, and then I would test in those spaces and say maybe it was negative, positive, negative, positive, negative. Okay? So we're still going to do the same thing we were just doing. It's just you also have to find the asymptotes. Okay? X-intercepts and asymptotes. Well, where are the x-intercepts in a rational? Zeros of the numerator. All right.
No, I don't.
You're wrong.
I'm lying. You're supposed to study.
Is this like mind school or something?
I'm cheating.
I hate this game.
This is
That's
like-
right. No.
This one's small.
What? Why did that?
Excuse me?
Are they like fractions?
Hey,
These are
he's
fractions.
brainwashing me already.
3 times 6 is 2, and then I multiply that by 2 again. 3 times 3 is 6. Oh my gosh.
You want to play a funny math game? These are called different bases or a modulus. No, numbers. We work in base 10 probably because, unless you live in Arkansas, you have 10 digits. So whenever I hit 10, I regroup to the next place value, right? This is base 4. So I go 1, 2, 3. There is no such number as 4. 10. I go to the next place value. 11, 12, 13. There is no such number as 4. 20. It's the next group of 4.
I don't understand that. And how would you get 3 and 2 is 11?
3 plus 2 is 5. 5 does not exist in a base 4. It is 1 more than 4. 4 is my place value grouping. 1 more than the next place value.
That is dumb.
3 plus 3 plus 2 is 8. 8 is 2 groups of 4. So 2 of the 10's place value. 3 times 2 is 6. 6 is 2 more than my place value grouping of 4. 3 times 3 is 9. 9 plus 3 is 12. 12 in base 4 is 3 groupings of 4.
I don't like this.
Let's play it again.
So, if y'all think that's entertaining, I'm just start throwing a random modulus problem up in the corner every morning and see who figures it out. All right. So,
I will not learn anything except for modulus.
now here's the fun part is modulus is actually used in more progressive schools to teach place value in elementary school because it reinforces the idea of when you regroup into a new place value. Yeah, it has nothing to do with... So, if I want to know where this particular rational function is greater than 0, I need to find its x-intercepts and its asymptotes. I can't do that while it's broken apart. Common denominators. Womp womp. X plus 1, x minus 6. So, up top, I've got 4x plus 4 plus 2x minus 12. Downstairs, I've got an x minus 6 and a x plus 1. Nope, just greater than 0. Combine like terms. 6x minus 8 over x squared minus 5x minus 6. Well, I see what the factors are, right? I'm doing this so that I have both the factored and unfactored forms. That way I can find my x-intercepts, y-intercepts, my vertical asymptotes, my horizontal asymptotes, all that stuff to determine the behavior of the graph. So, where would my vertical asymptotes be? Right? My zeros of the denominator. So at 6 and at -1, I'll have vertical asymptotes. Where's my x-intercept? Or where do I find it to begin with? Zeros of numerator. So 6x minus 8 equal to 0? 8/6 or 4/3. How many of you saw that on your tests? Reduce. Okay. Where would my horizontal asymptote be? Check the degrees. This is also why I wanted to. And when I take x divided by x squared, it doesn't go in there 0 times. Where would my y-intercept be? This is why I have my unfactored form. Yes. Plug 0 in. The reason I want that is because if my y-intercept is right here at 4/3, coincidence? Purely coincidence. Just because they were nice to you doesn't mean that they're interested in you. Okay? Purely coincidence. Ooh, hit an awkward teenage nerve there. The reason that I want to know that that y-intercept is 4/3 is it's going to tell me that it's positive there. I know that this is positive because I see where the y-intercept is. Don't I know that the general behavior of these things alternates? So if this normally goes here, and this is positive, then I know my graph does this. If I know it does this, then I know in what areas it's negative, positive, negative, positive. Now, I'm showing you the full tool set here.
Is there a shortcut? Wait. How did you get your x-intercept?
Zeros of numerator.
But then wait, how do you get that? Are there multiple zeros of numerator?
Not this time.
What about the other ones?
Other one what?
Those are the 4/3. I thought you were counting the 8/4.
X-intercept, I set this equal to 0, numerator.
No.
8/6 reduces to 4/3. But if I plug 0 in for X, I also get 4/3 for a Y-intercept. Purely coincidence.
Explain that again. So how did you get I understand you got the y-intercept, and how did you get the x?
Zeros of numerator. 6x minus 8 equal to 0. Well, okay. Fine. My factors.
You did that so weirdly, but taking out the 2 would have been. Yeah.
Well, set 6 equal to 0, nothing. X minus 4/3 equal to 0, 4/3. Office Max to the rescue. That color-coded version of, do we all need that again? If I have a x to the n math plus c over b x to the m remember that zeros of this guy get me vertical asymptotes. Zeros of this get me x-intercepts. Those are the things that I really need here because those are the things going on my number line. But if I also go find my y-intercept, and find my horizontal or oblique asymptotes, it can inform the behavior to tell me whether it's above or below an axis. Remember, if n is less than m, y equals 0. If n equals m, y equals a over b. If n is greater than m, divide, ignore remainder. Okay? Wouldn't the easier way be to find that exact spot on our video and then screenshot print what's right there on your laptop?
No way. I wrote it in my notes.
I mean, that would be the ideal version, since this is the third time I've written it up there.
I wrote it.
I could have sent
There
it
we
on
go,
the
I got
line, my picture.
Okay, so that stuff is still in play. Now, if I had, what was it, 6x minus 8 x squared minus 5x minus 6. After we got common denominators, we were here, right? I gave you the full tool set. It doesn't mean you need all of them to answer the question. Get your common denominators. 0 of numerator. x-intercept. Zeros of denominator, vertical asymptotes. Y'all, I could just plug numbers in. Yeah, it's open notes, open everything. Okay. I could test this right now by saying, I don't know, put a -2 in there. -12, -20, 4 plus 10 minus, so that's negative over positive is negative. Put a number between -1 and 4/3, whatever that is needs to stop. Plug in a 0, I get 4/3. Oh, look, it's positive. Plug in a 2. I'll get positive over 4 minus 10 minus 6, negative. Oh, wait, that's negative. Plug in something else, get positive. You don't have to do the rest of the graph. I'm showing you how the rest of the graph can inform the behavior. This is just, I got the red stuff, I plug numbers in. How about clear alpha? Come on, Frank, keep up. How about I go find my x-intercepts and my asymptotes? Which I know are at -1, 4/3, and 6. Y'all, could I just look at the screen and say that this is negative, positive, negative, positive? Yeah. As long as you got that cute little number line on there to show, I found these things and I tested in these intervals. I don't care how you test, but I'm still going to give you all of the different methods and all of the different tools. I've heard kids year after year after year, they complain about, rightly so, the teacher who counted it wrong because they did it a different way. I want to give you all of the ways so you can choose. And I'm not even giving you all the ways. I'm just giving you some of the most common ones. Okay? I want to give you the tool set and let you decide. So, this one's nice and easy. It's already set up for us. Start there. Oh. What was it? Fight. Negative infinity, -1, 4/3, 6, infinity. And they're asking what, greater than 0? Well, we tested and we found negative, positive, like that, right? So, positive numbers are bigger than 0. -1 to 4/3. Parentheses and parentheses because it's not equal to. Union 6 to infinity. What I want you to see, and this is why I make my number line like this, how does it change if I say greater than or equal to? Right? We would turn this into a bracket because it's an x-intercept. But these two are going to stay parentheses because they're asymptotes. and I can't touch asymptotes. This becomes bracket, but the others will stay parentheses because you can't touch asymptotes, and that's why I do my number line like this, showing the difference between asymptote and x-intercept. Okay? Yes, no touchy. So, start with 4a. Everyone to one side of the bus, common denominators, x-intercepts, vertical asymptotes, test interval. Remember, move the 1 to the other side. Common denominators first. Okay, now, you do you, but personally, I find I screw up negatives a lot less often if instead of saying minus fraction, I said plus -1 over thing. Because then I'll just distribute my -1 on the numerator. It tends to help me. Might work for you, might not. Just saying that's why I do that. Then we'll have x plus 6 minus 4x plus 3 over 4x minus 3. Getting -3x plus 9 over 4x minus 3. My x-intercepts come from numerator. my vertical asymptotes come from denominator. I'm making my number line and say I've got an x-intercept, so I'll make dot at 3. I've got vertical asymptote at 3/4.
Why is it minus 4x? Negative 1.
I subtracted 1 to the other side, right? So I have a negative 1 times 4x minus 3.
Wait,
Okay, I move my negative to the coefficient of 1 so that I could distribute a negative 1 into 4x minus 3. I screw that up a lot less often if I move my negative like that. Yeah. Well, all of my ADHD bouncing ball tangents, I've had kids tell me they learn more about history and psychology in here than they do in their classes.
Let's do 111.
Yeah. See, when you have to spend your life figuring out how other people work to survive, turns out that you get really good at psychology, sociology, and anthropology.
Yeah.
oh, it's right here.
Like 4. Like this.
Oh,
Oh, like the,
Yeah.
you mean like this?
no, like the answer, like, and you know what.
Yeah. Like,
Oh, okay. Are we getting to these? Okay. So we have a y-axis here, right? 0. No, I'm just showing you how I'm going to get it without plugging in any numbers. I'm not going to look at my calculator. I'm just going to know the behavior of the graph. You can look at the graph to just determine positive, negative. I know that I will have a y-intercept at -3. I also know I'll have a horizontal asymptote at, -3/4, -3/4. I mean, it might change how I make my graph, but if I know that these things love to alternate, then it's down here at -3 with a y-intercept. I know it's negative in this area. I hit an asymptote. It's going to go positive. I hit an x-intercept. It's going to go negative. And then it just goes to infinity. So that's it. Negative here and here, positive there. And it asks, where is it greater than positive or equal to, watch brackets, 0? There. But be careful that you put a parenthesis on 3/4 because it's an asymptote and you can't touch the asymptote.
I was confused on the process because I missed it. Is it ready for all?
Can it go who what?
I don't know.
you sure?
Yeah.
You don't sound sure. That sounds like the dismissive leave me alone, I'm sure. My passive aggressive meter is just right now, but all right. Again, that 4B. What? Okay. We got more practice on the next, on another slide. So.
I like it when they just already say equal to 0. You have to do it yourself.
When you make this over, can you put it like over 1?
I would, yes.
And then you like.
And then do common denominators.
Okay.
Yep. First, make sure that you got your words. Words are hard. Make sure that you moved 3 over and got common denominators and combined correctly. Now, I would absolutely love for every one of us to be able to sketch this graph by behavior. Doesn't mean we have to answer the question. Could I get a number line like so, put in my vertical asymptote at 2, right? Yeah. Put in my x-intercepts at -1 and 5, and then just screw it, look at my screen to see if it's above or below. Right? You still did the work. You did the work to get your function. You know what your vertical asymptotes and x-intercepts are. How you test those intervals is up to you. Personally, I might do 1, -4, -5, 2, 1, 2, -2, -4. Who cares? Personally, I might put in a y-axis with the line y equals x minus 2. So it's going to be 2, 1, -1, 2, 2, 3. I might do this. Doesn't mean you have to. If I know, but yeah, move over. Yeah. If I know it's going to do that, and then that, I can do it by behavior in a sketch. I never looked at my calculator. Who says you have to, right? Once you've got that number line, could you just test, get out of here, and say it's negative right here, positive here, negative here, positive here? Just look at your calculator screen and see where it's above or below the x-axis, because those are positive and negative numbers. And then answer the question. Where is that less than or equal to 0? Well, less than or equal to 0 is anywhere it's negative. So here and here. So from -infinity to -1, parenthesis or bracket, x-intercept, so it's going to be a bracket. From 2 to 5, parenthesis on asymptote, bracket on intercept. Okay? Those going okay? Like, it's taking everything from the last like 2.5 weeks and shoving it together in a single problem. And then Satan said, "Let there be words with math."
Are we still like on schedule?
Yeah.
We have one wiggle day.
One wiggle day.
To hit all of the content that we normally hit in PreCalc in the allotted time that we have left.
So that could be like taken if we have another snow day.
Yes. If we have a snow day between here and April 20 something, then I'm just going to do regular lessons when the junior testing is happening. And the juniors will have to make it up.
The day before.
The day of the junior testing.
Does that take all day? So he kind of wants
That's what I have scheduled right now. April.
Yeah, don't sophomores do pre-ACT?
April 19th and 20th is junior testing. April 19th afternoon is sophomore pre-ACT. I really want to take the 19th off in this class, and I have it scheduled that way right now, and with that, we still have a wiggle day. No. No. Doesn't. No. It's not often that I'm going to call a kid try hard, but come on. You don't need a prep day before pre-ACT. All right. So y'all can solve rational equations. Y'all can solve rational inequalities. Can you make one? Okay, words are hard, right? So English has never been my use's French word. A group of high school students is renting a bus for $600 to take to an amusement park the day after prom. A lot of throwing up. The tickets to the amusement park are $60 less or subtract minus an extra 50-cent group discount per person. So what they're saying is if one person goes, then it's $60 minus 50 cents. If two people go, it's $60 minus $1. Three people go, 60 minus 150, and so on. The more people you got going, the cheaper those tickets are going to get. Okay? What they're not saying in this problem, and they're just kind of assuming that you get this, is when the group of high school students is renting this bus for $600, they're splitting the cost. Okay? So it's $600 divided up among how many kids are going to go. Write and solve inequality that can be used to determine how many students have to go on the trip for the total cost to be less than $40 per kid. So, everyone's got to pay their share of the bus. How many kids are going? So, X. So we start with 600 over X. That's everyone's share of the bus. Then you got to pay for your ticket to get in. So $60 minus 50 cents per person in the group. 0.50x. So this is your share of the bus. This is your cost to get into the park. What will I do with these to determine your cost? How about I add them together? Okay. So bus plus ticket. And it says how many students have to go, X, to have everyone's share less than $40. So I set less than $40. And then you're off to the races. Okay, now they...
It's not fair. You said off to the races.
We were off to the races. We were off to the races.
No.
No.
Yes.
We expect our ransom.
Baby carrots.
Yeah.
Asparagus. Asparagus and baby carrots.
I think we stocked up fruit. Yeah, I think it should be donuts.
It's
Yeah.
it's $6 for 13 donuts at Walmart.
Yeah.
All right.
Split it up.
Y'all do what you're gonna do. You fight amongst yourselves another time. For now, let's do this. One of you just said, can I just multiply everything by X? Absolutely, because now I have a balance. If I didn't have a balance, if I only had an expression, no, you can't multiply everything by X. That would be like me just pointing at that table and say, triple. Like, what? It's just poof, 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 poof. There's 3 of each of them now? I can't just do that. Okay? But because there's an equation, or in this case, inequality, there's a balance to it. And because there's a balance, now I can multiply every term or both sides by X. You absolutely can do that. And that's probably the smartest way to do this problem. Is if I take the whole thing times X, I don't have to deal with denominators. So I get 600 plus 60x minus point. X over X. But that's why we're doing it, so we don't have denominator. Because if I put an X right here, they just cancel. Okay? You can absolutely multiply everything up here by X. And now it's just parabola. I would, yeah. I'm a positive kind of guy. I'm going to move everything over to the right, just so I have a positive leading coefficient. If I ever multiply or divide by a negative, I flip the inequality. I did not multiply or divide by anything. I just, yep. If it's absolutely. And if you did, if you multiplied by a negative X to get a positive coefficient right here, you would have had to flip the inequality. Yes. And now we're like, 8th grade, ow! Because we're remembering all this stuff about inequalities, okay? Yes. Oof. Yo, it's a parabola. I can solve a quadratic, a parabola, however I feel like. But right now, I want to know where this, for me, positive parabola is greater than 0. I'm going to cheat my way through this because it doesn't say how. I'm going to clear this out and say 0.50x squared minus 20x minus 600. Okay, now I want you to think about this. Because I subtract 60x from 40x. No, this is what I mean. Everyone just started pressing buttons. Think about a reasonable window here. What would you think, what is the maximum amount someone could pay? $660. $660. If one person literally rented a bus by themselves and just went by themselves. Okay? So $660 is the maximum that a person can pay because they have no friends. Because it's $60 for the ticket. So I'm going to make my window go from, my y's are going to go from the lowest cost we could have is 0. The highest cost I could have is 660. I'm betting I'm not going to go that high. Hold on. What about the x's? What's the least number of people that could go? No one goes. What is the most people that could go? It's whatever the capacity of this bus is, right? You ever seen the little sign in the front that says max capacity? What do you think would be enough kids to go on this? Okay. So we could go all the way down to free tickets if we had 120 kids, right? So I think that this window is ridiculous and extreme, but I bet I'm going to see it. I bet I'm going to see part of my parabola, right? And since I want to know when this is greater than, or sorry, greater than 0, for me, it's this. I find that number and I'll say that many kids or more. So maybe I change my window instead to go down to, my y's can go to -1 just so I can find my 0. Okay. No, that was way out there. That should have been like 30 kids or something. No, find the 0.
Yeah, that's what I got. But I also didn't change my window like you did, so I don't know if that's like this. I just unless I have the wrong graph in there. Oh, is it? It's not -0.5. I just have -5.
Yeah.
What's wrong there?
Extraneous. Because absolute value can't be negative.